Now let me solve the second problem. The question A. We just draw an example of this signal, and the higher one equals to 2, and the lower one equals to minus 2. And the x-axis is t, and this axis is x of t. And the second one, the probability of xt equals to 1. It is equal to the probability of the number of the random point arrive in 0 and t is odd. And it is equal to the probability of n 1 and the probability of n equals to 3 and the probability of n equals to 5. And so on, all the odd numbers. So this is equal to the e of the power of minus lambda multiply t, and then multiply lambda multiply t plus lambda multiply t with the power of 3. And so on, and then this is finally equal to 1 minus e of the power with the power of minus 2 multiply lambda multiply t over 2, so that we could find the probability of x of t equal to minus 2. It is equal to 1 minus the probability of x t equal to 2. It is finally equal to the 1 plus e of the power minus 2 multiply lambda multiply t over 2. And then the third question, we want to find the expression of xt, and xt only have two values. The one value is 2 and the other is minus 2. So we use to multiply the probability of xt equals to 2, and plus minus 2 multiply the probability of x of t equals to minus 2, and then we got the answer is minus e with the power of minus 2 multiply lambda multiply t. And the question D, we want to find r of t1 and t2, and it is equal to the expectation of x of t1 multiplied x of t2. And x of t1 multiplied t2, it is only have two values. The first one is 4, which is 2 multiplied 2. And the second value is minus 4, which is 2 multiplied the minus 2. And the 4 multiplied the probability of xt1, xt2 equals to 4. And the minus 4 equal to the probability of xt1, xt2 equal to minus 4. And this is equal to the equals to the 4 multiplied the probability 4 multiplied the probability of x of t1 multiplied x of t2 equals to 4, and then minus the probability of xt1 multiplied xt2 equal to minus 4. And it is equal to the 4 multiply the probability of in the t1 to t2, the k equals to even, minus the probability of in t1 and t2, the k equals to odd. And this is equal to the 4 multiply 1 plus e with power of minus 2 lambda multiply t2 minus t1 over 2, and minus 1 minus e with power of minus 2 multiply lambda multiply t2 minus t1 over 2, and it is finally equals to e with the power of minus 2 multiply lambda multiply t2 minus t1. And for the odd situation, both t2 bigger than t1 or t2 less than t1, we got the final answer that R of T1 and T2 equals to the e with the power of minus 2 multiply lambda multiply the absolute value of T2 minus T1. And the question E. From the above, we find that R of tau equals to e with the power of minus 2 multiply the absolute value of tau. So it is only the function of tau. So that we could say that xt is WSS. That's all the solution of the problem 2.